Why is Newton's law of cooling important for heat transfer? Imagine you have a hot cup of coffee and you want to know how quickly it cools down. Or think about a metal spoon left in a hot soup. How fast does it reach the temperature of the soup? These everyday moments are connected to how heat moves from one place to another. Understanding this process helps us design better cooling systems, improve energy efficiency, and even keep food safe. Newton's law of cooling is a simple way to describe how an object changes temperature over time. It says that the rate at which an object cools or warms depends on the difference between its temperature and the surrounding temperature. If the object is much hotter than the environment, it cools faster. If it's close to the temperature of the surroundings, the cooling slows down. This idea is especially useful when heat transfer happens through convection, which is when heat moves between a solid surface and a fluid like air or water flowing over it. In convection, heat moves from the object to the fluid or vice versa. Newton's law of cooling captures this process by linking the temperature change to the temperature difference. The law is written as a simple formula. The rate of change of the object's temperature equals a constant times the difference between the object's temperature and the ambient temperature. This constant depends on factors like the surface area, the speed of the fluid, and the properties of the object. For example, a larger surface area or faster-moving air increases the rate of heat transfer, making the object cool faster. Why is this law so important? Because it turns a complex process into a straightforward equation that can be used in many real-world situations. Engineers use it to predict how quickly a hot liquid will cool in a container, or how fast a computer chip heats up and cools down. It helps in designing heating and cooling systems, ensuring electronic devices don't overheat, and even in food safety to know how long food stays safe at certain temperatures. Knowing how fast something cools or warms allows us to control temperatures better. For example, in a building, understanding convection helps improve insulation and airflow to save energy. In manufacturing, it helps optimize cooling times for materials. In science, it allows researchers to estimate unknown temperatures by measuring how fast something cools. Overall, Newton's law of cooling gives us a practical way to understand and predict heat transfer through convection. It makes the principles of thermodynamics easier to grasp and apply in everyday life, from cooking to engineering. This simple yet powerful idea helps us see how heat moves and how we can manage it effectively.